Let's have a look at some methods to simplify server-side logging. The old way of doing server-side logging was to use the gs.log function. Let's exemplify the problems with this method by querying the incident table and then log some information from several fields in the record. Generating the log string is an advanced operation of pasting together string information with different pieces of information from the record. It is important to get the quotation marks and the plus signs 100% correct, otherwise you will get syntax errors or unpredictable results. Changing the log information afterwards is quite tricky. Along with the gs.log function to log entries with information level, it is possible to log entries with warning and error level with the functions gs.logWarning and gs.logError. Executing this script will give us the following result. The log information makes perfect sense. However, these methods to do server-side logging are legacy, and they have been so for a very long time. But many ServiceNow developers are still using these legacy methods. Now, let's achieve the same thing, but with methods that are supported, documented, and much easier to use. By using the function gs.info, we can write just one single string with the log information we want. Within the string, we can define placeholders where runtime information can be injected. The placeholders are numbers surrounded by curly braces. The placeholders are injected with the arguments following the log string in the same order as the number used in the placeholder. For example, number 0 is the first argument after the string, and number 1 is the second argument. Note that we don't have to paste strings together with quotation marks and plus signs. You can have up to 5 placeholders in the gs.info function. The gs.info function will log entries with information level. Similarly, you can do warning and error level logging by using the functions gs.warn and gs.error. Additionally, you can use the function gs.debug. This will create log output, but the log information will not write anything in the system log, thus saving database resources. Executing this script will give us the exact same result, but the code is easier to write and maintain. The debug level information is clearly marked in the output. Looking in the system log will show us all log information except the debug level log information, including the examples with the legacy log functions and with the proper log levels. If logging is done from within a scoped application, the log entries are also available from the application logs module. Let's talk a bit about GlideRecord alias functions. First, let me demonstrate the potential problem. Assume you do a GlideRecord search using the query function and the next function. This example with the GlideRecord search against the sys template table is pretty straightforward. The expected result is that the sys ID of every record in the sys template table is written to the system log. Let's execute this simple script. We get no output at all. This could easily be explained by the sys template table being empty and not containing any records at all. Let's verify that scenario by logging the number of records found by the query, and then execute the script again. The script tells us there are indeed 106 records in the sys template table, but why were none of these records written to the system log? Also, when listing the sys template table, we can verify that there really are 106 records in the table. This scenario can often take many hours to debug and understand. The key is in the table definition itself. Analyzing the table configuration, we can see a field with the label Next Related Table. Analyzing this field reveals that the field's database name is Next. When the script is trying to call the GlideRecord Next function, it gets confused. In the GlideRecord object, there are two occurrences of something called next, one field and one function. Now, the system do not know what to do. The solution is to use a GlideRecord alias function that exists to solve this kind of problem, namely the _next function. It is the same as the next function, but it can be used when the next name is already taken by a field, as in this example. Let's execute the script again, and now it works perfectly as expected. Similarly, there are also an alias to the GlideRecord query function, namely the _query function. Let's demonstrate this working. A good practice is to always use the GlideRecord alias functions _query and _next. Even if everything works today, you never know if someone will create fields with the database name query or next in the future. And all of a sudden your application no longer works. The GlideRecord alias functions will always be safe, since it's not possible to create a field with a database name starting with _. Let's have a look at why we should always strive to use the getValue and setValue functions in GlideRecords. We start by illustrating this with the potential problem of not using the getValue and setValue functions. In the first example, it will appear to work. We do a GlideRecord search against the incident table and limit the number of returned records to just 5 for demo purposes. When working with GlideRecords, you usually do some kind of operations to all of the records in the returned record set. In this example, we will write some information to the system log and to the screen. Usually, we just write gr.fieldName, in this case gr.number. So, we search the incident table, we limit the result to 5 records, we do the query, and for each of the returned records, we write something to the system log. Let's execute this script. Here we can see that we get the incident numbers, and they are all different, just as we expected. So, what is the problem? Well, the problem can be illustrated in another example. So I will copy this script, comment it away, and make a second example, example 2. We start the same way by searching the incident table and limiting the result to 5 records. But instead of logging the information straight away, I will do that later on. Inside the while loop, I will actually store the information in an array for later processing. For this purpose, I create an empty array, numbers. For each and every one of the returned records, I will push the incident number into the array for later processing, instead of writing it directly to the system log. I use the same gr.number when pushing the incident number to the array. We know this to be correct, since we validated the information on the screen in the previous example. Later on in the script, we will process the information stored in the array. Now we will write the information to the system log and to the screen. We do this with a for statement, traversing each position of the array. Then, instead of using gr.number when writing to the system log, we will use the information stored in the current position of the array. We expect this script example to give exactly the same result as the first example, right? We search the incident table, limit the result to 5 records. For each record, we store the incident number in an array, and later on, we traverse the entire array and write the content of the array to the system log and to the screen. We expect 5 different incident numbers. Let's execute the script. This time, we get a slightly different result. We don't get 5 different incident numbers. Instead, we get one incident number 5 times. We have actually lost important information from the GlideRecord query. If we do any processing or calculations on this information, we will not get the result we expect. What happened? And how can we correct this? Let's create a third example, demonstrating the solution and the best practice. We will do exactly the same, but with one small difference. Instead of using the gr.fieldName syntax, we will use the GlideRecord getValue function. So instead of using gr.number, we will use the getValue function and provide the field name as an argument. Note that the field name is provided as a string. When we execute this script, we finally get the expected result, 5 different incident numbers. This small change made a huge difference. The cause of the difference between the second and the third examples is not related to ServiceNow. It is related to JavaScript and the fact that JavaScript assigns values by reference and not the value itself. That is, what is stored in an array is a pointer to a value, not the value itself. The following illustrations will show what happened in JavaScript when we ran the script using the gr.fieldName syntax compared to using the gr.getValue function. First, when we execute the GlideRecord query function, a GlideRecord object is created containing the 5 different incident records. gr.number and gr.getValue are still unassigned. Then we call the next function for the first time. Since there is a record in the GlideRecord object, a pointer will point at this first incident record. When calling gr.number, a reference to the pointer and whatever it points to will be used, while gr.getValue will get a string copy of the value the pointer currently points to. Again, gr.number gets a reference to a pointer that may or may not move later on, while gr.getValue will make a copy of the value the pointer currently points to. When we call the next function again, the GlideRecord object will find the second incident record and move the pointer to that record. Again, when calling gr.number, we get a reference to the same pointer and whatever it points to now, while gr.getValue will give us a string copy of the value the pointer currently points to. Calling the next function again moves the pointer to the third incident record, and calling the next function again moves the pointer to the fourth incident record. Calling the next function yet again moves the pointer to the fifth incident record. gr.number still contains a reference to the pointer itself, and gr.getValue contains a string copy of the actual value. At the next attempt of calling the next function, the GlideRecord object determines there are no more incident records, and the while loop exits. Now we will traverse the array. In the example, when using gr.number, causing a reference to the pointer to be stored in the array, each position in the array will write the value of where the pointer currently is. Since we left the pointer pointing at the very last incident record in the GlideRecord object, this is the value we will get. Incident number 5 times. In the example, when using gr.getValue, 5 different string values have been inserted, copies of what the pointer was pointing at the time we made the copy. Do you realize the difference? Using the GlideRecord functions getValue to read information and setValue to write information is the safe way of working with the GlideRecord object. Make a habit of always using these functions instead of using dot notation to access the field. Finally, let's end with a small warning and awareness of invalid queries. Let's make an example. We make a GlideRecord query against the incident table. Let's pretend we want to delete all incidents that are currently put on hold. So we add a query to only get the incidents with the state 3. Now, before actually doing the delete operation, let's verify the number of incidents that will be deleted as a result of our GlideRecord query by writing to the system log and to the screen. Executing this script shows us that a total of 6 incidents will be deleted. That seems like a reasonable number of incidents. Now, let's consider the human factor and the possibility of making mistakes when writing the script code. Let's say the user fumbles on the keyboard and accidentally sets a query filter on the non-existing field state instead of the existing field state. A mistake that may be hard to notice when reading the script code on the screen. Now, executing the script tells us 54 incidents will be deleted. This is actually all the incidents there are, so the incident table will be empty after this operation. The cause of this is us. By accidentally creating an invalid query when referring to a field that do not exist when adding a query filter. Since the query is invalid, it is simply removed, and with no other query filters being present, the result is all incidents. This risk may be prevented by setting a system-level property. If not already present on your system, create a new true or false system property with the name glide invalid query returns no rows. Set the system property value to true. Now we will see that our invalid query returns 0 incident records instead of all. This will still be troublesome, but it is indeed better having a problem with no incidents being deleted instead of having all incidents deleted. Setting the system property to false recreates the default behavior of removing the invalid query and thus returning all records.